Alright, this is Unit 8, Simple Harmonic Motion, Topic 4. For this topic, I will be calculating the displacement, the velocity, and the acceleration for a system experiencing simple harmonic motion. This is the system here. It's a mass spring system, and it's undergoing simple harmonic motion. So, for the purpose of solving these equations, we're going to assume that in this system the frequency equals 1.87 Hertz and the amplitude equals 0.0191 meters. Alright, so the displacement. We can calculate the displacement of the object at any point in its oscillation using the equation x equals amplitude times cosine 2 pi frequency t. T in this equation is the time, since we're calculating the displacement at a certain point in time in its oscillation. For this problem, we're going to find the displacement at 1 second of the oscillation. So for this, we plug in x equals 0.0191, which is the amplitude, times cosine 2 pi times 1.87, which is the frequency, times 1, which is the time. And that gives us the answer, x equals 0.0131 meters. And that is the displacement at time 1 second. So using that, we can find the velocity. And we can calculate the velocity with the equation v equals positive or negative 2 pi times the frequency times the square root of amplitude squared minus displacement squared. The velocity we are calculating here is the velocity at t equals 1 second again, since we're using the displacement, which was also at t equals 1 second. So for this equation, we plug everything in, and we get v equals positive or negative 2 pi times 1.87, the frequency, times the square root of 0.0191 squared, which is amplitude squared, minus 0.0131 squared, which is displacement squared. That equation results in the answer velocity equals positive or negative 0.1633 meters per second at time equals 1 second. Alright, so moving on to acceleration. Again, it's the acceleration of the system at time equals 1 second. We calculate the acceleration at any point in its oscillation using this equation. Acceleration equals negative 2 pi times the frequency squared, and all of that is squared, times the displacement. So we plug everything in, we get acceleration equals negative 2 pi times 1.87 squared times 0.0131. That results in the answer of acceleration equals negative 1.808 meters per second squared. An important note for acceleration is that it is always directed towards the equilibrium position. It's trying to bring the mass back to equilibrium because of the spring, spring force. The force of the spring is trying to bring it back to its equilibrium position, and that is why the acceleration is always directed towards the equilibrium position. So that is Unit 8, Simple Harmonic Motion, Topic 4. Alright.